So, hello everyone. My name is Tarush, and we are going to do another theory topic of physics, energy method in SHM. So, basically, this topic is very important from JEE perspective because last year only one question came that could have been very lengthy with the normal method of solving questions, but by energy method, it took like less than 5 minutes for JEE Advanced, 3 minutes, let's say, for JEE Advanced. So I'll just solve that question also, but first we need to understand the theory. As we know that total energy in an SHM is always constant. We all know that because we have studied JEE syllabus once and we are going for extra topics. So we know that total energy is constant, which is the sum of kinetic energy and potential energy. So uh, if like for the energy method, the theory basically is that if we find the equilibrium position of particle undergoing SHM, and then and then after displacing by some distance, say x, we write the total energy possessed by the particle and differentiate it. It will come out to be zero. Now, how can I say that? I'm just saying that ET is constant at any time of the SHM, right? So at any time, if we differentiate the energy, it will come out to be zero. DET with respect to time. Differentiate it with respect to time. It will come out to be zero. Uh, One point to discuss that why aren't we differentiating it at the neutral position is that at the neutral position, at like mean position, it is like the velocity is maximum. So energy total will basically be half m a square omega square just because of the kinetic energy, and there will be no potential energy. Differentiating it will you will get zero, but you will not get any help in finding the omega or the time period. So basically, the main motive of using this method is to find the time period or the omega that will help us solve the question. So I will explain this with an example. I will solve the example by three methods. Two are one is the basic method, one is basic. Then the other is the energy method, one energy, and the third is also energy, but I will follow a different path. You will understand why. Okay, so the basic question from which we started HM is this. All right. Neutral position is this is in gravity is there. Mg and some force will be there. Let's say Kh, right? So they cancel out at in mean position. Kh is equals to mg, so we don't need that. Now, uh, if we displace this by let's say x, this is displaced by distance x. So the force applied will be Kx, and we know that Kx is equals to m omega square x in negative. Basic derivation, you must know these things. Like after coming this far away, plus only. This is the mass. So this the mass is m, right? Yes. Omega will be root k by m, and time period is 2 pi by omega, which is 2 pi root m by k. Simple. Now energy method. Simple, we start like this only. M above force kh, below force mg, and like after displacing it, the by a little amount, let's say uh, x, it will be having some velocity here, right? Because you are displaced it, so either here or here, but it will be having the velocity in this direction only. Why? Because we have displaced it here, so in this direction, in minus j cap direction. So it is having some energy in the form of speed, right? Like during the motion. So we velocity here, and what all will be right in the total energy is the question. So total energy will include kinetic energy plus potential energy. Kinetic energy of spring, no massless spring. Of this box, yes, half mv square. Plus potential energy of this box, yes, because this there is some gap, right? Uh, mg and mg minus mgx minus mgx plus uh, then half k h plus x whole square. Why h plus x? Because initially kh is equals to mg in the neutral position. We know that it is not unstretched spring. It is in a stretched position with the elongation h. So mg is equals to kh. Yes. So we have this is total energy. So ET, we know the equation. Now differentiating it with respect to time, what we'll get half m 2v dv by dt, product rule, minus mg dx by dt plus half k 2 times h plus x into 0 plus dx by dt. I'm just writing it. So dE, and this should be equal to 0, right? Cancels out, cancels out. mv dv by dt is acceleration minus mg dx by dt is velocity plus k h plus x into dx by dt is velocity equals to 0. Velocity, velocity, velocity cancels out because of course at this point it must not be 0. So m into a minus mg plus kh plus kx is equals to 0. Now, here what we observed was kh is equals to mg. So kh and mg cancels out minus plus. So ma is equals to kx minus kx. We again got to the conclusion of this thing only, right? Acceleration is minus omega square x into m is equals to kx minus kx. Minus minus cancels out, x cancels out. So omega comes out to be root k by m, and time period comes out to be 2 pi by omega, which is equals to 2 pi root m by k. You must be thinking this is a lot of thing for this easy question, but now let's do the third method. What was the third method is that in SHM, in energy method, you can ignore constant forces. This is a very important statement that will help you in like almost every question in SHM, is that you can ignore the constant forces. So what was the constant force here? Gravity. Just ignore that. At a distance x, velocity v, half mv square plus half k x square. We are not considering any gravity here. We are excluding it both initially and both finally. So we get total energy as this ET. Differentiating with respect to time, dEt by dt, we get half m 2v dv by dt plus half k 2x dx by dt. 2 cancels out. mva plus kxv equal to 0. Vv cancels out. M omega square x is equals to minus kx. And again, we got omega root k by m. Time period 2 pi root m by k. So this is an important method that you must ignore constant forces while solving these type of questions. You can ignore that. If you won't ignore, that will just increase the number of steps that you will take to solve the question, right? So now let's do another question. Just to explain, now we'll just do by energy method. Uh, let's say this is a pulley of radius r, mass is m. connected to a spring which is connected to floor, and let's say there is enough, the moment of inertia of pulley is I. Okay. And there is enough friction between pulley and thread to prevent slipping, between pulley and thread to prevent slipping. Yes. So after we displace it a little, let's say it comes out to be here and the spring is elongated, right, by this length is x. So what will be the total energy? Of course, it will be possessing some velocity v. So half mv square is permanent, and then half kx square, because of the x elongation here will also be x elongation only, x half kx square, plus half I omega square. Now, why I omega square? Because moment of inertia of pulley is also given, and this is also rotating while we are moving it downwards, right? When we are moving this box downwards, this pulley is also rotating, something like this in this direction, right? In by something of angular velocity omega. V is equals to r omega. Just solve this. How? Et is equals to half mv square plus half kx square plus half I omega is v square by r square. So we can just differentiate it. Det by dt is equals to half m 2v dv by dt plus half k 2x dx by dt plus half I by r square 2v dv by dt. 2 cancels out everywhere. MVA plus KXV plus I by R square into V into A equal to 0, because this is 0. Yes, that's what the theory says. MA plus I by R square into A is equals to minus KX, A common, M plus I by R square is equals to minus KX, A is minus omega square into x is cancels out, minus minus cancels out. Omega comes out to be root k by m plus I by r square, and this is what the omega was is given. Time period is 2 pi by omega, which is 2 pi root k root m plus I by r square by k. Yes. So this is the answer. This is the basic theory. Now we'll move to the JEE advanced question of 2025. That I thought would be lengthy with normal method, but easier by the energy method. Okay, so this is the question that came in JEE Advanced 2025 last year. You can try to solve this question once, and then I'll show you the solution as well. I will need the figure, so I'm copy pasting it here. Yes. Okay, so one thing, let's read the question. The center of the disk of radius r of mass m is attached to a spring of spring constant k inside a ring of radius capital R, and capital R is greater than r. So, okay. So the other end of the spring is attached on the periphery of the ring. Both the ring and the disk are in the same vertical plane. The disk can only roll along inside periphery of the ring without slipping. The spring can only be stretched or compressed along the periphery following the Hooke's law. Okay, so the spring is basically is inside this periphery. Okay, so it can't come like this. Okay, in equilibrium, the disk is at the bottom of the ring. The disk is at the bottom. Okay, uh, assuming small displacement of the disk, the time period of the oscillation of this is t is equal to 2 pi by omega. Then we have to find omega. Okay. Here, one thing to consider is that all the terms are considering G, and you will say that constant forces, how are we taking into effect? So one thing is that here, initially it is under support. So initially there is, even if there is a force mg, it is being neutralized by a force normal, right? So here we cannot say that it is a constant force, because even after coming here we will get mg at an angle theta, let's say. and this will be mg cos theta, and this will be mg sin theta. And here the normal will only balance mg cos theta, only one component. So this will always be there. So this is changing. This is not a constant force. This is changing with theta, right? So here we will have to consider the effect of gravity. This is an important point that these type of questions you should consider. And like not these type of questions, you should also think yourself also that it is changing, force of due to gravity is changing with theta. So we will have to consider gravity here, right? Okay, so let's consider the solution now. How to solve this question? You can try it once on yourself, but I'll share the solution. Here, let's, yes, the ball is here. Let's see. Rearranging it. Yes. And the radius of the ball is small r. This is small r, and this big radius is capital R. So the radius from the center of the this disc and the ring will get as capital R minus small r, subtracting this length, right? This one, two, three, this length, subtracting this length. So we get R minus small r. So we got this. Uh, Now what we'll do is initially the potential energy and final the potential energy will be from here and here. Yes. So this is the delta y, the change in the height, right? Total energy is equals to kinetic energy plus potential energy. At this point, kinetic energy will be due to omega and due to velocity because we are moving it against the force. So half mv square plus half I omega square. We would consider pure rolling because nothing is given. So v equal to r omega, right? In pure rolling, and plus then potential energy half k x square. Now we don't know that what is x because this is elongated, right? So this is in a slant length, slant. So what we'll do is r minus r times theta is basically the extension, r minus r times theta, or you can say that x is equals to r minus r times theta, right? We will put the values later on. Plus half. So delta y. Initially, the system was here. So it was r minus r. Afterwards, it became r minus r times cos theta, right? So the basically the length change caused is mg r minus r 1 minus cos theta is equals to total energy. The question is finished. How? I is equals to mr square by 2, right? We get half mv square plus 1 by 4 mv square by omega is equals to v square by r square cancels out, plus half kx square plus mgr minus mgr minus r cos theta is equals to et. Now det by dt we get half m 2v dv by dt plus 1 by 4 m 2v dv by dt plus half k2x dx by dt minus this differential will come out to be 0 because this is a constant value, minus mg r minus r cos theta minus sin theta, and d theta by dt must be equal to 0. This cancels out. This becomes 3 by 2 mva plus k xv minus m plus m g r sin theta into d theta by dt, which is basically omega, is equals to 0. Mg r minus r sin theta, mg r minus r into sine of theta. Again, we are displacing it by a very small length x. So theta is tending to 0, but it is very small. So sine theta is tending to theta. And then we can say that sine theta is equals to theta is equals to x upon r minus r, right? This only. We got the same expression. So now using this expression, x is equals to r minus r into theta, 3 by 2 mva plus kxv plus mg r minus r. First of all, substitute sin theta as theta, and omega is v upon r minus r. R minus r cancels out, equal to 0. 0. V cancels out, 3 by 2 ma plus kx plus mg. Now theta, what was theta? Theta was x upon r minus r. X upon r minus r equals to 0. Minus 3 by 2 ma is equals to kx plus mg x upon r minus r. A is minus omega square x. So minus minus cancels out. 3 by 2 m omega square is equals to kx plus mg x upon r minus r. X cancels out. So omega comes out to be root 2 by 3 k by m plus g upon r minus r. What option is this? 2 by 3. G upon, yes, this is A option. And A was the answer given by Advanced 2025. So, see, took 5 minutes, but yes, it was easy by energy method. Just try total energy and differentiate it. By doing it by the basic method would take time, I suppose, but I didn't solve it by the simple method. Energy was way easier, so I preferred the energy method. You can also try to solve this by normal method, but energy method was way easier. So this is omega, and try to solve all the questions that you have done in SHM by this method, and you will find this method to be more interesting than that. Okay, so let's meet in the next video. That's all for today.